Alright, we're going to pick up where we left off in our last video. We are going to multiply more complex numbers, but this one's interesting because there are no i's visible, but we do have square roots of negative numbers. So our very first step is going to be to rewrite these factors with I in them.
Okay, let's break down these square roots. And once you get a feel for this, you can just do this kind of by looking sometimes. So square root of 4 times square root of -1, then plus square root 5 times square root -1, and then in our second factor, square root 9 times square root -1, and then last one, square root 3 times square root -1. All right. So everywhere we have an I is going to get everywhere we have a square root -1 is going to get replaced with I. And then any square roots that we know, we're going to take them. So we know square root of 4. We know square root of 9. The other two that we don't know without a calculator, we're going to leave those because those are irrational. So let's just keep rewriting this and then we'll multiply. We haven't even gotten into the multiply step yet, but this is necessary first. So we have 2I from our first term over here. Then we have I and a square root 5. I'm going to put the I in the front just so I don't accidentally think it's underneath the radical sign. Then I have over here 3I. And then the last term, it's going to be square root 3I. But again, I'm going to put the I in the front so that I don't accidentally think it's part of the radical. Okay. Now that I did that preliminary work, I am ready to multiply. So I'm going to go ahead and use the box method again. And we're going to let's just write our first factor on top. So 2I plus I square root 5. And we'll write our second factor on the side. So 3I plus I square root 3. And there we go. We're ready to start multiplying. So first box, top left corner, 2 times 3 is 6. I times I is I squared. Top right corner, notice you have a positive term because it's positive times a positive, so I'm going to put my plus sign. Square root 5 and 3, we can't do anything other than multiply those because the 3 is not inside the square root with the 5. So we have to leave them like that. And then we have an I times an I, so I squared. Okay, bottom left corner, positive again because it's a positive term times a positive. We have a 2 and then a square root 3. We can't do anything other than just multiply them like this because one's in a square root and one is not. And then we have an I times an I, so I squared. And then our bottom right corner, we have positive. Notice, let's start with the square roots. We have square root 5 times square root 3. Those are both square roots, so we can combine them and say that it's square root 15. And then we have an I times an I, so that's I squared. All right. Now, I'm not going to say anything like terms because unfortunately they're not because we have different radicals, but we can simplify everything. Everything that has a I squared is -1. We talked about that. So let's take everything from inside our box and every term that has an I squared, which is all of them, we are going to replace with -1. So 6 times -1 plus 3 square root 5 times -1. And then let me move down, plus 2 square root 3 times -1. Plus square root 15 times -1. All right, and let's make this look a whole lot better. So we have in the first term, -6. The second term, so that was this one here. The second term, we have -3 square root 5. That's this one here. The third term, we have -2 square root 3. And then our last term, we have negative square root 15. And I know that answer doesn't look very nice, but this is the answer. So it's kind of funky looking, but that is it. And so nothing can combine because there's no like radicals. So this is exactly as simplified as it can possibly get. Okay, so let's see. What do you think the conditions are for adding and subtracting complex numbers? Well, it's very much the same for adding and subtracting radicals. They have to be like terms. Okay, so let's see. We're going to add. Okay, so let's see if you can see it intuitively. If we were to add these complex numbers, these are all actually technically imaginary, they're all going to have an I in them. So you can combine them because they're all like terms. If you want, you don't have to do this step, but let me just show you. You can factor out the I. So this is 2 plus 4 minus 5 times I. And so you have a total of, let's see, 6 minus 5, so 1I, which we would just write as I. Or without even factoring it, you could have just said 2 of something plus 4 of something is 6I minus 5I. So there's just 1I left. Okay, how about here? This one's a little different, number 7. This time you have to focus on the like terms because there's different ones. There's real parts here, but there's also imaginary parts. So we have to combine the real with the real and the imaginary with the imaginary. So we have 5 plus 2, which is 7. And then the imaginary is 3I plus 5I for a total of 8I. So you have to combine real with real and imaginary with imaginary. And how about subtraction? The very first thing you have to do here is actually distribute this minus sign. So we'll do this one in 2 steps. We have 5 plus 3I. And then if we distribute, we have a minus 2 and then minus 5I. And then let's identify like terms. We have 5 and negative 2 as the real parts. And then we have 3I and minus 5I as the imaginary parts. So just like before, we're going to combine like terms. 3 for the real. And then 3I minus 5I, so a total of negative 2I for the imaginary parts. And that would be the result there. Let's try one more. Okay, so right here we have lots of things going on, but the very first thing we need to do is anytime you have a square root of a negative number, you need to replace it with an I in it. You need to rewrite so that it has an I in it. So let's see. I'm not even going to do anything else but other than focus on where there's an I. So we have square root of 4 plus square root of 8 times square root negative 1. Okay, this is my very first step. Then we have a minus sign, square root 9, and then plus, notice 2 is on the outside, so that 2 is going to stay. And we have square root 2 times square root negative 1. Okay, now I'm going to start simplifying, but my very first step was to take any square root and rewrite it with a negative 1. So then let's break some stuff down. We know square root 8 has a perfect square in it. If we separate this as square root 4 times square root 2. And that's the only one we needed to break down. Okay, so in the front here, we have square root 4, which we know. This square root 4 we know. This square root of 9 we know. And that's it. And then also, everywhere we have a square root of negative 1, that's going to get replaced with an I. So let's go ahead and do that. So we have 2 from the square root 4 plus this square root 4 times square root 2 is 2 square root 2, and then the I that it was multiplying by. And then we have in the second quantity 3 plus 2 square root 2 times I. So make sure you're not writing the I under the square root in either one of these. If you need to, put the I in the front of the square root just to avoid that. Now we're going to distribute our minus sign and do our subtraction. Okay, so we have, and let's do it in 2 parts, 2 plus 2 square root 2I minus 3 minus 2 square root 2 times I. And so let me just highlight it again so you recognize what's like terms. The real parts are the 2 minus the 3. And then the imaginary parts here are the parts with the I in it. So 2 square root 2I minus 2 square root of 2I. So let's put those together. So the real parts, 2 minus 3, negative 1. Notice the imaginary parts, and this is a coincidence. This does not always happen, but the imaginary parts add up to 0. 2 square root 2I minus 2 square root of 2I. So those actually add up to 0. So you can say something like plus 0i, or you can just say -1. So both of these answers would be correct. All right. In the very next video, we are going to multiply and divide complex numbers. So this was a brief introduction to operations on complex numbers, and we'll keep going in the next video.